Exercise 3.3 Problem 1 Division 1 Discussion. Find the zero of the quadratic polynomial and verify the basic relationship between the zeros and the coefficients x square minus 2x minus 8. So this is the polynomial. We are asked to find the zero of the quadratic equation. That is basically roots of the quadratic equation. You have to equate x square minus 2x minus 8 equal to 0 and find the roots of it. Then we also need to verify the basic relationship. What is the basic relationship? That the sum of the roots is minus coefficient of x divided by coefficient of x square. Product of the roots is constant term divided by the coefficient of x square. So we need to check that. Okay, so let's put out the steps, but I'll be doing all this discussion only for this one. Further some similar sums, we'll straight away go into the solution. Okay, so given p of x is x square minus 2x minus 8, and we need to calculate zeros of the polynomial p of x and verify the relationship. So what is the relationship? Sum of the zeros is minus coefficient of x divided by coefficient of x square. Product of the zeros is minus constant term by coefficient of x square. So here coefficient of x square is 1, coefficient of x is minus 2, and the constant term is minus 8. Okay, so if you get the zeros, add the zeros and find the value on the right hand side using these coefficients and see whether they are equal. Similarly, find the product of the zeros on one side and find the value of the right hand side using this polynomial and see whether both are equal. This is how we need to verify the relationship. Okay, so step 1, factorize p of x. The first step is that we need to factorize this, equate the factors of 0 and get the zeros of the polynomial p of x. Then check whether now you have the zeros, add the zeros so that LHS is known. Now RHS is minus coefficient of x divided by coefficient of x square. You know the coefficient of x is minus 2 here, so minus of minus it becomes 2. 2 divided by coefficient of x square is 1. See whether the LHS and RHS are equal. Similarly, find the product of the zeros on the LHS and now evaluate the RHS. So what is RHS? Constant term divided by coefficient of x square. That is minus 8 divided by coefficient of x square is 1. So it is minus 8. See whether the LHS and RHS are equal. Okay, this is how we need to do the problem. Let's get into the solution. The polynomial is x square minus 2x minus 8 and we need to factorize this. Okay, actually this should come early. So we need to factorize. How will we factorize? Multiply the coefficient of x square, which is 1, and the constant, that is minus 8. So minus 8 must be factorized in such a way, when you add these factors, it should get you the coefficient of the x. That is the rule. Okay, now minus 8, you can write it as minus 8 into 1 or minus 4 into 2. Okay, minus 8 into 1 does not suit us, but minus 4 into 2 suits us. Why? Minus 4 into 2 is minus 8. Okay, it's a mistake here. It is this minus sign here. And at the same time, minus 4 plus 2. Okay, minus 4 plus minus 2, right? Minus 4 plus 2. This is again, no, it's not, it's a plus 2. Okay, minus 4 plus 2 is minus 2, which is nothing but the coefficient of x. So minus 4 and 2 are the factors of x. Now to be doubly sure, how will you do? You have to divide this by the coefficient of x square. What is the coefficient of x square? So it will become minus 4 by 1 and this will become, dividing it by coefficient of x square, it will become 2 by 1. Now the factors will be x, that is, this will become the coefficient of x. So 1x minus 4. Then 1x, okay, plus 2, whatever is the value here, that comes. So the factors are x minus 4 and x plus 4, x plus 2. So p of x is x minus 4 and x plus 2. Now we equate it to 0, you will get a product of 2 are 0. So if you equate this to 0, you will get x is equal to 4. When you equate this to 0, you will get x is equal to minus 2. Right? Now we have the zeros of the polynomial. So the zeros of the polynomial are 4 and minus 2. Let's check it out. Put p of 4. What is p of 4? Substitute x is equal to 4 in the polynomial. So it is 4 square minus 2 into 4 minus 8. So 4 square is 16 and 2 into 4 is minus 8, and then this is minus 8. 16 minus 8 is 16 minus 16, that is 0. So x is equal to 4 is a 0. Next we need to check p of minus 2. So p of minus 2 is minus 2 the whole square, right? This is the function, right? This is a polynomial, right? So minus 2 the whole square, okay, then minus 2x, minus 2 into minus 2 and minus 8. So this is 4 and this is also 4. So 4 plus 4 and this is minus 8. 8 plus 4 plus 4 is 8. 8 minus 8 is 0. Right? So the zeros are there. Now, that's the zeros of p of x are 4 and minus 2. Next. We need to find the sum of the zeros. So zeros are 4 and minus 2. The sum of the zeros is 4 plus minus 2, that is 2. Right. What is the product of the 0? 4 and minus 4 into minus 2, that is minus 8. Now what is the relationship? Sum of the zeros is minus coefficient of x by coefficient of x square. We know the polynomial is x square minus 2x minus 8. So what's the coefficient of x? Is minus 2. Coefficient of x square is 1. So as per this equation, minus coefficient of x is minus 2. Coefficient of x square is 1. So this is minus of minus becomes 2. 2 divided by 1 is 2. What is your sum of 0 is 2. So both are equal. So the first relationship is proved. Next, product of the 0 is constant term by coefficient of x square. What is the constant term? It is 8. Coefficient of x square is 1. So it will be, constant is minus 8. So minus 8 divided by 1, that is minus 8. And what is the product of the 0? Here it is minus 8. So the relationship is also proved. Okay. So first thing we'll have to factorize the polynomial, equate it to 0, get the zeros, then check the zeros by substituting those values of x and see the polynomials are becoming 0. Once that is 0, find the sum of the zeros and the product of the zeros and use the formula for the sum of the zeros and the product of the zeros. That is sum of the zeros minus coefficient of x divided by coefficient of x square, and for product of zeros we have constant term divided by coefficient of x square, and check whether the relationship holds good. Okay, so this is how this problem needs to be done, and I hope I made it clear. If not, please go through one more time, it will become clear. Thanks for watching this video.